developers, we are geospatial experts and users, and we are all, just like the name implies, about open. So we work with the world to make geospatial information findable, accessible, interoperable, reusable, open. And that's what we're trying to contribute to the metaverse. Knowing that it's not the metaverse, as in like one metaverse, but how do we build together an open metaverse? And how do we leverage the amazing work of this geospatial community in 3D, modeling, simulation, streaming, AR, VR at scale? Or like I told Mark and Patrick on their podcast, Building the Open Metaverse, shameless plug, Patrick and Mark, if you want to put the link in the chat, everything we do in OGC is applicable to the metaverse. So we have an amazing lineup today with the objective, I hope, of not just talking about the metaverse, but actually showing what we're doing and really trying as a community to figure out the gaps for standards or best practices that the geospatial community can help work on, develop, evolve, profile to create this vision of the open metaverse. And speaking of the vision of the open metaverse, very thankful to Patrick and Mark for championing really this vision with action and with this attitude of collaboration and partnership. So our lineup, as you see the agenda here, will start with Mark Petit, and we will close it with Patrick Cozy as they sort of sandwich this discussion that's going to cover the journey going from geospatial data to the metaverse, to gaming engines, to applications. And as you listen to these amazing speakers here, I would urge you to think about whether it makes sense to continue this conversation. Do we need a working group with an OGC that's dedicated to open geospatial standards for an open metaverse? And maybe we can find some good acronym for this. But with no further ado, I'm going to give the floor to Mark Petit. Mark is the general manager of Unreal Engine at Epic Games. And Mark, the floor is yours to set the vision and get us kicked off.
Well, thank you, and my apologies. I'm technology challenged, as you can tell, and I'll be brief because I think you are, the panelists are the real experts. But I, Nicole asked me to talk about the M word, the big M word, so I'll talk about it. I think maybe give some context, some definition. For me, the metaverse is the extension of the internet to real-time 3D. So the metaverse is the internet. We don't build the metaverse, we build for the metaverse. And the current web and social experience are relying on digital pictures and digital video. And now what's happening is the commercialization of a new medium called real-time 3D. And for me, that new medium is essential because of two characteristics. First, it gives agency to the user over the content. And I think that's very, very important. That interactivity is the heart of the experience. And then it's multi-user and therefore social at its core. So in the metaverse, the experiences are interactive, social, and who knows, they could become immersive if we ever get some comfortable hardware. I'm hopeful, I'm positive. But that interactivity and that social first aspect is I think what makes the big difference with the traditional internet. Of course, we would need co-presence. And if one day we get this sense of co-presence, those platforms will become highly essential in our family life, in our social life, in our professional life. So we need that co-presence to improve the comfort and the sense of being truly social. I think it will happen too in due course. It may take years to get there, but it doesn't matter. So because those platforms will have such a deep impact on our jobs, on our social life, and our family life, I think I want to remind everybody that as an industry, we have a collective responsibility to build them right, and to build them fair, and to build them open. And I think that's also some of the spirit that we're approaching this with Nadine and the OGC today. So, and you guys know well, because you're living this every day, that the world of GIS has been significantly and hopefully positively impacting by real-time 3D technology. And that both true what's happening on the web at what's happening with game engines. Glad to see Sebastian from Unity here, because game engines are really changing the game for GIS. And one of the best examples of combining those two things is Cesium. And Patrick, all the work that you guys have been doing at Cesium. Last week at ITSEC, there was a lot of other proof points of that. The collaboration between Esri and Presagis on Velocity 5D was particularly, I think, notable for me. And a lot of other, I'm not going to mention all of them. I'll mention one because we were involved in the XR version of Project Anywhere, a lot of plugins from GRM. So there is a lot going on, and and we're blown away by the work you guys do. Like I see Gaston, I see Rob from Aerometrics and Black Shark, and all you guys. I mean, so I'm going to pass on the floor to you guys because I think those new technologies are really enabling for GIS, and they will allow you, as Nicole said, I think that the science of knowing where things are is going to be hugely important in the metaverse. So back to you guys. I look forward to hear from the specialist now.
Sounds great. So I would say let's talk a little bit about data in the metaverse. And Apurva Shah, the CEO of Duality, is ready. Go for it.
Thanks, Nadine, and thanks, Mark and Patrick, for inviting me as well. So we can just go maybe to the next slide. So a little bit about our team, our DNA, essentially. So my co-founder, he comes very much from the physical side. Mike is a mechanical engineer, part of the DARPA team that kicked off the whole self-driving car revolution. My home, on the other hand, is in the virtual, very much building these worlds like the Paris and Ratatouille, or the underwater world of Finding Nemo. And when Mike and I started chatting back in 2018, we felt that essentially humans learn through storytelling, and frankly, that's also a way for autonomous systems to learn, right? If you're going to really make autonomous systems that are truly dynamic and adaptive to their context, there's only so much that programming them specifically will get you. They kind of have to learn on their own a little bit. And that insight is sort of what got us started. We've been fortunate in having an amazing team, very grateful, working with us from across the world. We are very pandemic, very much a pandemic company in that sense, the distributed team, but a singular focus. And we have some amazing partners. Obviously Unreal as a 3D operating system has been critical. I know Aubrey, I know where you're sitting, Aubrey. We were at the Digital Twin conference just yesterday. So nice to see you again. We can go to maybe the next slide. So again, because Nadine made the point, let me make the point that when I say the metaverse, I mean it in the sense of the web. It is not a singular thing. It's a concept. It's a collection of useful things, and that's kind of our vision is to build a metaverse for solving real world problems, essentially. And so digging into that a little bit more, I think if you can go to the next slide. So I actually also, I'm a technologist, but I teach designers at California College of the Arts because I feel that this, often don't have designers at the table early in the process, and it's so important, right? Technologically we can build lots of things, but then we expect other people to come in and clean up our mess afterwards. And so part of the reason to teach designers is to try to give them a seat at the table much earlier in the process. And because the word metaverse is thrown around a lot, I think it's important to sort of define it a little bit. And so the way I kind of frame it for my students is really as this, first and foremost, the metaverse is a space. It is synchronous, shared, persistent. And it's very important, again, that, users are embodied within that space, that can navigate within it immersively, can interact with it, through direct presence. I mean, these are really, really important attributes, and which is really what makes it a different medium. Right, it's different than a 2D web, which is very, very canvas-based. You can go to the next slide. Another thing that I've found really useful in really thinking and talking about the metaverse is to bring into focus this concept from interaction design of the core interaction loop, right? So whether it's a human navigating a physical space. I mean, we are very much using a perception stream in real time. And then whether you have a wet brain or an autonomous brain, it's going to make some decisions based on these inputs. And then there's an actuation stream. And again, we call these things streams because they're not really discrete. These are continuous functions. And a lot of synchronicity for the metaverse really comes from the fact that, can you do this fast enough to give the brain the illusion that it's happening in real time, that it's happening continuously, just in the way that a movie plays back at 24 frames a second. We can go to the next slide. So our work is much more, centered on the enterprise metaverse. And so just to sort of put it in that framing, the heroes in our metaverse are actually digital twins, right? Because they are going to basically operate within these spaces and learn from them, validate how they're going to operate in a particular space, certainly provide visualization, end-to-end optimization for these kind of spaces. And it's worth clarifying that these are not mutually exclusive, right? So you can have a metaverse with digital twins that are teleoperated or fully autonomous, and you can combine them also with human avatars, which actually opens up, if you think about it from the standpoint of a modern warehouse, which might have a bunch of robots and humans essentially collaborating, if you will. It opens up opportunity for really exploring those kind of spaces, developing for them, training for them, and really thinking about operating and optimizing them. We can move to the next slide. Interestingly, just to sort of bring back that core interaction loop, you can see that it looks actually exactly the same. Definitely at this point, the sensor streams are originating from this synthetic environment, from this virtual environment. But again, if you do our job right, those streams should be interchangeable with the physical world. And similarly, the actuation stream should be using the same control stack, the same, should be predictive in terms of their physics and their mechanical behavior, so that, again, what you're learning in the metaverse can be essentially permeable with the physical world. So that's part of the key to getting this working. And of course, we are all collectively at the very early stages of this journey, right? But if we can make the data, the behaviors, the interactions permeable between the physical and the virtual, that is the real promise, I believe, of this enterprise metaverse. And we can go to the next slide. So this, I don't know if we can actually play back a short little clip of Falcon in action. If not, we can just move on as well. So I think if you click on it, it should open up Vimeo. But if that's not possible, we can share the link later. Thank you. Yeah.
All right. Thank you, Apurva. And anybody, if you have any questions, just put them in the Q&A and we'll get to them either here or later. But we want to hear from you as well. So thank you for getting us kicked off on the metaverse. I love your definition. So Gustavo, can you take it from here? So I'm sorry if I'm going to pronounce your name wrong. So Gustavo de Figueiredo.
Pretty good.
Senior VP of Strategic Partnerships at blackshark.ai, who I also met last week at ITSEC.
Excellent. Thanks, everybody. Thrilled to be here. Thanks for the opportunity to be at such great company. I think I'm going to apologize in advance for my hoarseness because ITSEC took the best out of my vocal cords last week. So the occasional roughness here, I apologize in advance. So for those who haven't interacted with blackshark.ai's technology, we basically state that we are in the journey of building a 3D digital twin of the infrastructure of the planet, right? Can we advance to the next slide, please? But some of you may have already interacted with us. You just probably don't know this, but we're the Austrian company behind the Globe in Microsoft's Flight Simulator. And so we got our origins in solving the problem of reconstructing what's on the surface of the planet, but with a set of constraints that forced us to have to take unconventional approaches. The first thing is we sought out to build, and I love Mark's definition of a metaverse. So basically, we're building a world of objects, all the objects that we can detect on the planet. And so we start from the ability to detect, distinguish, and consistently name and retain objects on the surface of the planet. But the other problem that we're trying to solve is how to do this at scale. There's, depending on how you count, 1.4, maybe 1.5 billion buildings on the planet. And then you can add trees and other objects, that gets into the trillions very quickly. And so we had to devise technology to do this at very large scale, very fast, so that we could support Microsoft in its goal of creating a realistic environment for people to fly. You could call that a metaverse, maybe, yes. It's an environment where people can interact with the real, but it does miss a couple of other things, right? The other piece when we think about metaverse is that you have to solve for tens of thousands or millions of simultaneous interactions. So think about folks playing the game. You have to stream this content in a way that's not going to swamp the network. And so we had to adopt some foundational technologies in terms of enabling users to dynamically get the globe streamed to them in a highly efficient manner. Can we go to the next slide, please? This was actually intended to be a build. I guess we lost that. But the way we do this is we start from the most pervasive source of data about the planet, which is satellite imagery. We can also use aerial or drone imagery, and we apply AI and computer vision algorithms to detect and map what is on the surface. Those algorithms do things like detecting whether something is a building, a single family home, a high rise, a shopping mall, roads, vegetation, water bodies, etc. This gives us a semantic 3D map of what is on the surface of the planet. And in this foundational 3D map, that's where we start the process of creating a consistent, persistent representation of what is there. And then the next step for us is to then create a synthetic environment. So the data lives inside a database that's accessible via APIs and can be exposed semantically for both humans and machines to consume, but the visual representation is important. And so in order to do that, we start from that semantic data, and we've devised technology that enables us to reconstruct those buildings in 3D inside Unreal Engine or Unity and texture them with familiar facades. Note that we started from ortho imagery, so we had no information about facades. So we devised technology that enables us to assign facade structures and constructs that are what you would expect to find in a region of the world. That said, in order for us to do this, we had to create a methodology, a language, call it, to describe what is there. And that's essentially how we solve the problem of scale. We're streaming this very compact language into the clients so that we enable high performance, high frame rates, and consistency. So bottom line, we believe there is something that is essential for digital twins in the metaverse is for us to be able to create this consistent, call it ontology, call it hierarchy of objects on the planet. I look forward to the opportunity to collaborate with folks here in this panel and the OGC more broadly on how we can advance this this construct of a way to identify objects, consistently map them, consistently see their properties and their representation across platforms.
Thank you. So the question, I see a couple questions, so we can get to them later, but we've covered the interaction between real and virtual. We've covered the digital twin, and I like, Estelle, how you kept saying consistent ontology, consistent environment, because we're gonna need it for this open metaverse. So with that, I'll hand it over to you, Rob. So Rob Cloud is next. He's the sales manager at Aerometrics, and I bet he has some cool stuff to show.
Thanks, Nadine. And yeah, again, delighted to be here with the panel. I think I've mentioned a few times some of these guys on the panel. They're my spatial heroes, and yeah, we rely heavily on these guys to make us look good. So really, really proud to be here. So I work for a company called Aerometrics. We are delivering 3D photogrammetry, and we're starting to see that 3D photogrammetry really become a stable input for a huge range of industries, whether that be BIM, whether that be AEC, whether that be virtual production, whether that be gaming. We're starting to see 3D data really becoming prevalent pretty much everywhere. So the metaverse was really just the next step for us, and we're really starting to see it's just a culmination of what we've all been doing up until this point. And what we're seeing is that same data is the same data that's being used for the construction of the real world, and that same data is now being used for the construction of the virtual world. But that's the key, is it can't be two completely separate things. And often when we talk about the metaverse, it is that integration of the real world and the virtual world. Whereas I think if you see some of the presentations, including Mr. Zuckerberg's very impressive presentation, where it was all about the virtual world. It is that integration with the real world that is going to be crucial for the success of the metaverse. If you just go to the next slide, please. And what we talk about when we talk about 3D becoming prevalent, if you could just press play, please. Thanks. What we're talking about is products like this, where we need 3D data to be something that's not just small areas, not just single buildings, but citywide, even larger. So some of the projects that are happening down here in Australia, we're talking about statewide 3D data and statewide digital twins. And that 3D data needs to be something that can be experienced not just from the air, but from the ground. So for an example, here in Melbourne, we need to be able to go down to the ground level, go down to the alleyways, and be able to see that data and get that realism that is going to get the engagement of the public. So this is a well-known laneway, smack bang in the middle of Melbourne. This is AC/DC Lane, one of my favourite places in Melbourne, where you can really start to see that if you're trying to get the engagement, you're trying to get that virtual experience, we really can get down to that level. So just going back to the beginning of that alleyway, we can really start to see where we can now start to take this data and integrate it at a whole different level than we've done before. Imagine this type of data with a HoloLens and the idea that virtual presence, and you can really feel like you're actually now in that AC/DC laneway. I can go and have a look at one of these stickers that are on the wall, and I actually can read the details of that. But the key to this is it doesn't need to be just something that looks good. If you can just go to the next slide, please. The key to this is it can't just be something that looks good. For this data to really become useful, it needs to be accurate. So everything we do is controlled to survey, so therefore people can rely on it, and therefore they can integrate it with their GIS, they can integrate it with their engineering data, they can integrate it with IoT sensor data. It needs to be reliable, but what's key, and this is where a lot of the people on this panel come in, it needs to be easy to use and fast to access. And the work that's being done by pretty much everybody on this panel is enabling you to become faster to be able to access. It needs to be interoperable, which is why we're here. So I need to be able to take that model and be able to view that model in all the different applications, and for me to be able to trust that that data is going to be able to be used in all the different applications we've got. And crucially, one of the things that really makes this become even more reliable is it needs to be time aware. So it needs to be something that when I look at it and I make some decisions on it, I need to know, crucial metadata, when it was created, when it was, the data was, up to date. But ideally, I want it then to become something that is then updatable on a regular basis. If you can go to the next slide, please. And one of the things that's really changing the data and what's really going to enable the metaverse, if you press play, please. So, oh no, go back, please. You should be able to press play on that, please.
Doesn't look like that video it came through correctly.
Okay, all right. So what that video was going to show, and actually you can go to Patrick's webinar. So what it was going to show was we're now obviously working with people like Esri and Cesium to really start to make that data intelligent, where I can now actually click on any aspect of that video and be able to get the attributes of the window, the attributes of the pillars, the attributes of different materials. So utilizing, and again, I'm going to give a big plug to Patrick here, utilizing 3D tiles next is a huge step for us, where now this really does become an intelligent mesh model. And therefore we can classify the windows and therefore have different materials attributed to that, which when I then take that into Unity or Unreal Engine, that material can then have different activities attached to it. Maybe I want that window to have a certain level of reflectance, for the weather to have a certain impact on that material. But I gave a presentation a few hours ago to a BIM organization, where now this same model, because every single textile can now be have that semantic metadata that 3D Tiles Next is enabling, I can now integrate that 3D model with my BIM. I can integrate it with my asset management. I can integrate it with my GIS. And it really becomes a living, breathing, intelligent mesh model. That's what's going to drive the metaverse, is not just something that looks amazing. It's got to be something that's intelligent and usable. So that same model that we just showed in San Francisco, if you can just press play on this. Nope. Can you press play on the video?
Yeah, it doesn't look like this one came through either.
Oh.
If you have the link, feel free to share them in the chat. I think that
I will do. So what the video was going to show, and this is a company called Luniverse. So this is somebody that's already utilizing that same data that we just showed to really drive the future of the metaverse, where we can now wander around San Francisco, collect NFTs, collect different tokens that will enable me to walk around that same building that we just saw in San Francisco, collect a token for coffee, and then use that token I've just collected in the virtual world to actually walk into the coffee shop and actually get that free coffee that I've just collected. So when we talk about the metaverse, in many respects, the metaverse is already being done. So we always look at the future of the metaverse, but so much of the metaverse is already happening. And again, I think when Patrick and the Cesium guys launched, Cesium for Unreal, and within a few minutes of the launch, people were flying around Denver and walking around Union Station. That showed that we already have people integrating with virtual worlds, and we already have people that are beginning to live in virtual environments. And if anybody watched, still one of the best presentations I've seen was Philip's colleague, at the Esri UC, where he was flying and walking down the main street of Bendigo, and then having the weather effects where he stood in front of a virtual production screen, put his umbrella up because he was getting rained on in the middle of Bendigo. So much of the metaverse is already here. The key is just that interoperability, that reliability, and I've said it a lot in all my presentations, collaboration is going to be key. And I'll give a big plug, Patrick and Mark, your webinar, your podcast. That's one of the things that comes across really strongly is that collaboration. The metaverse is not going to be done by one organization, it's going to be done by collaboration. And I think all the people on this panel will agree with that. It's an exciting time, but we've all got to work together to get to that point. Thank you very much.
Thank you. Thank you, Rob. And if you have links to the videos and you want to put them in the chat while the others are presenting, that would be great. I'm totally in agreement. I think everybody was shaking their heads about the collaboration. And I love how it's just like ITSEC was a great example because it's sort of happening organically. A lot of the demos at many of the booths were, collaboration at least between three entities: data providers, digital twin, 3D people, modeling simulation, engine. Philip, since he pointed the finger at the Esri demo. So Philip Milkey, 3D Web Experience Product Manager at Esri, you want to share your perspective?
Sure. Yeah, well, we're definitely seeing signs of it now already, but we have about say 4 or 5 years until the practice of GIS is really fundamentally transformed by this convergence of technology and capabilities and expectations. OGC and this open standards panel really helped to make this metaverse, not a multiverse. And so we're investing a lot in game engines and so that we can transmit services for consumption in Unreal and in Unity. And we have a lot wrapped up in how our user base is approaching their evolution right now. And so in a lot of cases, the importance of a digital geospatial in the metaverse we see is ultimately the index for how this content plays into the larger conceptualization of digital twins. Do we have video? Or, okay, great. What I wanted to talk through is just a couple of our, the capabilities that we're seeing around our user base, and a lot of themes that I've heard already in the podcast. I'm already a big fan. So in December, we're releasing the our industry or our interior positioning systems, and we see the convergence of real-time data and 3D as absolutely being one of the main drivers that we're starting to understand here. So with this IPS, understanding where people are in public safety scenarios or just trying to better understand traffic, it's one of those great examples here of bringing together real-time data consumed through people as sensors, as IoT, and how that gets transferred into a 3D visualization. A lot of aspects here in terms of GIS and 3D GIS being social comes with editing. And so in this case, example, just editing a simple pre-plan template here within a building scene layer that's been consumed from Autodesk's Revit. This is also something that we're really happy to see, this kind of editing experience that can happen over the web, just really enabling people to solve their specific problems and to communicate using geographic data. One of urban here, this is an example here around vertical zoning and sketching multiple scenarios and really seeing the effect that that ends up having on the character and the skyline of the city. And a lot of that also in the social aspect of it is constituent engagement and communicating with people. What if we build a building here? What does that ultimately look like? These are use cases that are being driven by our users. And in a lot of cases, this ends up becoming really beautiful representations. Voxel scene layer is something that we are actually just releasing. In this case is volumetric data that's representative of temperature, salinity within the ocean, and it gives us the chance to display large volumes of data over time and displayed in a variety of different ways, kind of unencumbered by geometry, which helps to just, I think, give a beautiful visualization of scientific data. And this is something that now we're working to stream over the web through a voxel scene layer. So we'll see this through our own i3s as another scene layer type. Some of Rob's beautiful data here streamed over the web through Scene Viewer or through our JavaScript API. And this is an opportunity to see the combination of, I guess, a system of reality capture and a system of record come together into the same place, which just makes a huge difference for understanding these kinds of things. And that kind of data then ends up playing well into this convergence with game engines. And what I think game engines ultimately bring is this simulation space, really not only the representation of lighting and atmospheric effects really well, but actually seeing things move and understanding some of the characters and the behaviors with agent-based modeling, and really giving this impression. Like there are strengths that are occurring far beyond our platform, and being open and working together on this is important. But a lot of this can also happen over the web. Beauty can happen over the web. We have a user in Norway that is producing these this visualization with LiDAR, vegetation, and then with some of our atmospheric or our water effects here. And I think that's just it's a good example of like just beauty possible. A little audio here for you for the time being, but one of the other analytical things with this is an opportunity to show shadow change over time. The music will disappear soon, and that this is one of the things that ultimately brings 3D a value for geospatial and solving new problems. So that shadow, line of sight, understanding visibility and the interaction that occurs with visibility is like inherent 3D analytical products that people want to solve problems with, and they look to a lot of different platforms to be able to do. Geospatial plays this huge role within this. What's the elevation? What's the slope? What's it look like when you go skiing? How fast are you going to go down? But 3D is also a container for temporal analytics. This is a space-time cube representative of monthly water consumption, and it gives a water company the opportunity to actually review that kind of consumption. Another theme is remote sensing. So the same data through aerometrics and through other sources, being able to bring that together from a remotely sensed sensor ultimately couples this this experience of like high resolution integrated mesh to really gather that precision that's necessary to really understand, to digitize data, to understand that data behind it, all the attributes that are associated with it, and in a lot of cases to drive a variety of experiences. There's not a digital twin for one purpose. Ultimately, technology is a means to an end, and the beauty within web mapping, I think, in a lot of these cases, produce a wide variety of ends. And so, being able to understand and click on the big blue bear here is pretty valuable. But another thing that's valuable with remote sensing within 3D and the metaverse, this is FEMA with Hurricane Waldo. We're able to reduce the number of people that they were sending into field, putting into harm's way, and really gathering an information product that identifies the amount of damage that has occurred, so that they were able to really deploy resources without it being a big danger to the staff that's on the ground, and to reduce those costs. And they were doing that with remote sensing and working within the 3D GIS to really ultimately understand this changing picture of time as this response strategy was coming into place. So it's another interesting example here as far as how the metaverse can come into play to help to make people safer. So I think then, to kind of cap this out, open standards and interoperability is also a big value for us. So we used we're incorporating Chronos standard with KTX2 for mesh quantization to ultimately be able to make our visualizations more GPU friendly, so that it's a reduction in the memory that's being used, and to ultimately stream this integrated mesh through our i3s open spec much more performant, so that it can be available for a wider variety of purposes with the kind of speed that's necessary in order to be able to visualize this. We've been working with Loaders GL to really work through a conversion mechanism for 3D tiles and for i3s. The work that Patrick and Cesium has done has been amazing, and so the need for interoperability is absolutely there. philosophically, we're in the same mindset with working with OGC and open standards. And by that same vein, being able to bring I3S into Cesium, or in the future to be able to read 3D tiles in Esri's platform, I think helps to bring our worlds together a little bit more. And like we said, it's a metaverse and not a multiverse, and so that we can work together through these services. It's not really about operability, is not about exchanging files, but actually being able to review and view live services. And so I think that's something that that we're ultimately committed towards growing towards in the future with some of the resourcing that we're applying to this. And finally, these cooperations, these organizations, like with what we'll be working with Bray's conversation, is the interrelationship between Autodesk and Esri to ultimately produce GeoBIM, and the space that is played between AEC and the visualization that occurs with the larger context of GIS, but then the specialization and the connectedness of being able to directly view and work with that BIM data as it comes from. So a lot there, a lot that's in the work, but ultimately we're just so excited to be here and to be a part of this conversation. So thank you.
Wow, thank you, Philip. I think I feel the same pain as Rob, the data integration. If you had to, do all of this without standards and interoperability, it's just what you showed would be overwhelming. And I also appreciated the how you started with the evolution, really, of GIS. It's the evolution of the internet, and I think part of everything we're seeing is, in a way, this is what we had in our minds 20 years ago, but now we can actually finally make it happen. So it's very exciting. Yes. So once again, I love how you're handing it over to the next person. So Bray, you're it. Bray Tucker is Senior Industry Manager at Autodesk, and he's going to help us with the GeoBIM integration, I guess.
Yeah, and more. So I think I had a presentation, but I'm not able to upload it. So I think I'm just going to have to do this with the old voice box here. But ultimately, where I think the story starts is how so many of our tools are changing, right? So Autodesk for the last 40 years has been focusing on different industries and essentially having a bespoke application for each industry. So you think about design versus media and entertainment versus manufacturing. Each one of these applications now has its own software. So it's Revit, or it's AutoCAD, or it's Inventor. And as we started to invest more in Forge, one of the things that was interesting about that for us as a journey, Forge became something so much more interesting than just this way to connect with desktop applications. It was a way to kind of mix and make the best use across applications. So an ecosystem of development led to a lot of new microservices there around translation, interoperability. And now we're thinking about the future of that platform. And what's interesting about collaborations with Esri is that we're starting to unveil kind of new ways of working, what that means in terms of digital transformation for companies that are delivering work. So project execution turning into now this concept of digital delivery. There's so many new types of data problems that are going to happen where people want to have a bespoke way of measuring success on one type of project. And then that needs to have a data profile that can be captured. And then that data profile is going to be unique, maybe on the next project from a similar company, but a different project. So Autodesk challenges are kind of wild because the platform itself needs to be super flexible. We're supporting a lot of interoperability with Bentley and Trimble and Leica, trying to find more ways that we can just make the platform successful. So I think in this conversation of the metaverse, interoperability and how you play with data, it's the number one problem, because the second you turn on a really large data source, it becomes a gargantuan task to even think about how am I going to even move or activate data in one way where I need to, tell this very different story. So I love all of the videos from Esri where you get to see science in action. Those data sets are actually enormous, though. So one of the really interesting things about Esri and Autodesk coming together, the main technical differences between a GIS system and a BIM system, one is very much rooted in a real world coordinate system. So it's dealing with the curvature of the earth, it's locating things on a plane that's changing. And then in a BIM environment, we're kind of like Newtonian physics, we're in a Euclidean coordinate system. So when you try to make those things match up, it's almost impossible, right? So GeoBIM is actually a very, very clever solution where it's mixing coordinate systems, it's getting it about right, close enough for most things. And I think that's a really interesting interoperability story, because that's not something that should be possible, right? Like that building, when we design them, for the most part, we're designing them kind of in this vacuum of space where we say the ground is flat and we're going to dig into it and we're going to try to make flat floors. But if you're in a really large environment, like an airport where you're dealing with, you know, lots of long runways, you actually feel the curvature of Earth in some of those works. So it's an interesting space, because I think now when we talk about the metaverse going forward, we're going to have content creation, which Autodesk supports in a lot of various ways. And from a Pruva's background in Pixar, media and entertainment is a really big part of that, right? So how do you make things? How do you texture them? How do you rig them? Just in this whole complex world of just, you know, other unique types of data. So I think Forge is kind of Autodesk's future for that. We're really investing heavily into what that platform can mean for not just one industry like geospatial, or AEC, or even media and entertainment. The metaverse is going to just definitely rip all of our industry definitions apart, because it's going to be much more about, hey, how do we actually just show all this work that people have been doing for decades and activate it in a simple and intuitive way? Because I think that was kind of some of the really interesting things about the internet when it first really kicked off. It was, hey, we're connected, what do we do with that? And I think the metaverse is going to have kind of similar things. Once we're really interoperable and our platforms be able to play with each other, it's going to be that kind of problem all over again. So that's where Autodesk is very excited to be a part of that conversation, and very happy to be here and collaborate with companies like the ones that are on the stage today. So I'll leave it at that. I've got a couple of videos that I'll drop in the chat that kind of show off what we're doing with Tandem and what we're doing with our project delivery solutions. And I think those are good examples, because ultimately what you're going to get is an understanding of, these are web platforms that are built from Forge. So it's an indication of, these are things you could be building too. What kind of ideas do you have? That's really the future that Autodesk wants to be in, where we're building up foundational services that are interoperable, but then you have a platform in this environment that you can develop upon.
Thank you. This was even better than a presentation. Thank you so much. I noted two things. I don't know if I heard it correctly or not, but when you were talking about mixing coordinate systems, you said we're doing something that should not be possible. I love it. And the other thing I noted down is we're ripping all of our industry definitions apart. It's not these verticals, because we gotta have to cross to create this, virtual world and have it interact with the real world. Well done. Thank you. So Seb Lavier, head of geospatial at Unity. How are you gonna top that off?
It's really hard, because I do not have the beautiful videos that you've seen, so it's like it's just going to be my head talking. So bear with me. No, and I get to kind of be second to last, and I'll let Patrick do his magic. But no, I'm as I'm listening to you guys, and I love the progression of what the way we've set this up, because it kind of, from our perspective, being a game engine, what we get to do, and we actually get to consume all this beautiful data and do some, and let our creators and our users actually do something with this. And we're struggling with the Black Shark and Aerometrics and all this beautiful data coming in, is basically we're going beyond pixels, essentially going beyond simply scanning the world and actually making sense of it. And I love the idea of ripping apart every industry and actually, redefining. And, in geospatial at Unity, I actually get to span horizontally throughout multiple verticals, and I get to challenge things. I might be annoying sometimes, but that's what I get to do, to actually challenge people who actually are thinking about this. But so what does it mean for us from a consumption perspective, what does it mean to explore the metaverse? And I agree with everybody who said that it's not going to be one single place. It's going to be the advent of geo-contextual computing, whatever you want to call it, 3D within the internet. And the internet analogy, I think, is good because we don't know where we're going to land. But, you know, my colleague Timini and I, we talk a lot about contextual computing. It's about geocontextual computing in this case, meaning, okay, we've got a whole lot of data, right? And we're getting more and more of it. And for us, our challenge is going to, how do we make this data meaningful, and how do we create context for our users where the environment resolves itself to be useful, right? So think of, I'm exploring the world for a given purpose. As a user, I want the environment to resolve itself for it to be useful. I just don't want to get bucket loads of pixels, right? So that means a lot of things. It means that, first of all, there's not a single definition of things. So we talk about semantic, and I want to go back to this, and Gustavo and I we've talked about this, and thinking about semantic is, what are the objects in the world that I want to interact with, and what is the relationship to these objects, and how do I make sense of that? And there's actually no one single definition of semantics. So what we're working on is actually not only, or else we're trying to do Esperanto, in other words. I mean, we're trying to build one single language for everything. And it's actually, when you look at how a biologist will view a tree, for example, is not the same thing as if you're a game designer and you're thinking of a tree maybe as an obstacle in a racing game. A biologist will think of a tree as, you know, a bunch of cells and bark, and I mean, all that biology does, right? So let's just say there's not a single definition of things. Now, where the OGC specifically, and the purpose of this conversation, where this can help, is the mechanisms by way we contain definitions of things and the mechanisms by way we resolve them. So semantically, interoperability for me is a process, not a dictionary. And that is something that, you know, we can spend some time on. But I think, you know, to be able to benefit from what all you data providers trying to do magic to actually make sense of these scanned environments, in the end, we're still going to have a data problem on the other side where, you know, if my mother can make use of the environment, then it needs to make sense to her. So our human brain does it very well, but we're far from being there. So semantic maps, absolutely, relationships, definitions, and yeah, that's where we are. And then, you know, optimization and anything that we can do. So our job at Unity, we're working with all of you, and you know, Esri, Cesium, bringing all this together, combining and fusing all these sources of ground into one thing, and then publishing out to applications that can be whatever, whether or not it's a game or industry specific or very targeted application. So that's our vision. That's what we're trying to do. And I think we're just at the first days of that conversation.
Thank you, Seb. You did it very nicely. So I noted I like this, the geo-contextual computing, and then it's semantic interoperability, not a dictionary, to make sense of the environment from different perspectives. So I'm going to be totally honest with everybody on the line and with every speaker. We have saved the best for last in this session. So that's Patrick Cozy. He's, you know, the CEO of Cesium. And I honestly think he's who brought us all together. That's the reality. He brought us together at SIGGRAPH. He's bringing us together in his podcast with Mark. And he's definitely, you know, I think between him and Mark, they're being the bridge so that we can rip apart everything, not just the verticals, but also across the technologies. So really happy that, you know, Patrick, you can help us make sense of all of this, and I'll leave the floor to you.
Wow, thank you, Nadine. I don't know if I can live up to that introduction or that I deserve it, but I really appreciate it. And just, I mean, first, thanks to you and to OGC for giving us the forum today, and big thanks to Mark for bringing so many people here to speak. I mean, my first comment is this whole session makes me very, very happy. I think we had 7 presentations and 7 presentations covering 3D, right? And sorry about that. A lot of my work and Cesium's work has been right at that intersection of 3D and geospatial. So to see so much 3D here with this OGC meeting, it's just really, really fantastic. I think it's the most exciting time in computing when you look at all the eras of computing, from PC to internet to cloud to mobile. The metaverse, I think, is the most exciting time because we have all these foundations, both at the hardware and software and device layers that are laid, that now we can build these really interesting experiences on. And as part of this, I think it's the most exciting time to be in geospatial. So I'm really, really thankful for that. And I really like that Rob said the metaverse is the accumulation of what we're all building, all the speakers here, but also everyone in the audience joining us today. And just like the internet, where maybe you couldn't pinpoint exactly when it was here and it was constantly evolving, right? I think we're reaching a critical mass where the metaverse it's a real thing, and it's a real word, and we're going to keep evolving that, and we're going to keep building that together, right? It's bigger than all of us and all of our organizations, and it's that collaboration that's going to allow us to build something that's going to be truly, truly unique and truly special. So I think OGC is going to play such a central role, right? And because we need the interoperability, we need all the software and all the devices and all the tools that we're building to work together. And in order to get that interoperability, we need these open standards. In order to get these open standards, we need a forum in which we can collaborate. So I'm really thankful to Nadine and OGC for providing OGC as one of these. But there's not going to be just one standards definition organization. There's going to be many. And I loved the connections to Kronos that I heard today from Esri using the KTX2 for texture compression. And I think we're going to see many different standards organizations working to facilitate this interoperability, this collaboration. And that we should look for ways to leverage work that's being done across many different disciplines. A common theme that I saw today, and was very pleased to see, if you look at the data from Arametrics, you look at the data from Black Shark, you look at the data coming from Autodesk, is it's massive scale, and we care about not just the geometry, not just the textures, but the semantics behind that, right? It's one thing to see a 3D city or a 3D terrain. It's another thing to know what building is that. Is that a door? What way does that door open? So one thing that Cesium has been doing in collaboration with OGC and in collaboration with Kronos is creating an OGC community standard called 3D tiles to allow us to take that massive scale data and then stream it. And we started with Cesium.js, which is a 3D visualization engine for the web. And you can go in there and you can walk through the world at very high resolution, and it only streams in the part that you're looking at. And then something magical happened when we built this bridge to Unreal Engine, and I felt like we made 10 years progress overnight, right? I feel like suddenly, the decades of investment in game technology was unlocked for geospatial, and then likewise, all of this 3D geospatial data became available to the game technology. And that's just one example of when we create these open, interoperable ecosystems, how we can just move the field forward as fast as possible. And I'm not joking when Nadine and I are chatting and I tell her, I just turned 40 and I'd like to see how much progress we can make in my lifetime, right? Part of the open strategy and the open philosophy behind Cesium is somewhat selfish in that I really want to see how far we can take the metaverse. And I believe to take it far fast, we need that open interoperability. One plug I do want to make is we're advancing the 3D tile spec to support better simulation and also more fine-grained and precise metadata. There's a link at the bottom of this slide. I'll also put it in the chat, but we would love feedback. It's all on GitHub. And then the last plug, if we could go to the next slide. I think we've talked about it once or twice, but Mark and I organized this Building the Open Metaverse session at SIGGRAPH, which is the ACM conference for the Special Interest Group in Computer Graphics. And we just thought it'd be great to bring together folks working in the graphics world to talk about how we're building Metaverse in an open way. And from the time we submitted that idea to the conference to when the conference happened this past summer, Metaverse became very popular, and our 2-hour session kind of exploded with, I think, at least 12 different presenters. So it was very clear to us that that conversation needed to continue. So we got the idea to, hey, let's do a podcast and let's bring on the actual folks who are building the open metaverse and let's amplify their message. And we ask very simple questions and we let them talk. And it's really, it's the podcast that we both want to hear with, I'd say Mark is the responsible adult and I'm the geek. And Nadine has been on it as well. So I think it's a great thing to check out. And one mantra we have that I'll leave everyone with is a bias to action, right? What are we going to do now? Nadine, what are we going to do?
All right, thank you, Patrick. We have plenty of things to do. We have to look at the questions. That's the immediate to do. Before we get to that, I just want to give Mark another opportunity. We opened with you, Mark. Now that you've heard what everybody has said, did that meet your expectation of connection, collaboration, geospatial, and more?
Yeah, no, absolutely. I think, hearing all of those declaration of intent around interoperability is fantastic. I think we just have to live up to the expectation that we set for ourselves. But I may be optimistic, but I think, the industry, especially the GIS industry, is a great place. And again, it's the foundation of many things. So I think there's a lot that you guys can do to show the way to other people who tend to be a little bit more or less in the interoperability mindset. So let's do it together and let's show them what we can do.
Sounds good to me. So think about not just our speakers, but also the audience, if we should set up some sort of a working group to put maybe actually be explicit about those gaps, the data integration, the semantics. There's a lot of work, the 3D, and then we can essentially keep track of those as this little group that holds other groups and even other standards organizations sort of accountable and collaborating with us. So think about it. And let me, we have a few minutes. I'm going to start with a couple of questions. I like how everybody's, really jumped on the Q&A. So I like this question from Stephen Amor from Euclidean. And he says, let's face it, humans are the only entities that need visualization of models. Computers, AI, robots, autonomous have their own models and with quite distinct need and attributes. And to date, these models are segmented, duplicated. So Stephen had two questions. Let's see. Is the metaverse finally the platform where one overall model is useful to every type of entity? I think we sort of answered that question already. And we have one version of the truth. And the other question is geospatial information then the hub that brings the whole metaverse together? Is geospatial the only thing that is consistent amongst every user type? Who can handle this?
I'd like to take a crack at this, if I may, right? I think there were some great points brought across the discussion and the presentations. I think Bray said, hey, here's the internet. We're now connected. What do we do? And if we remember, and I'm going to be dating myself, is that all of that connectivity started from the fact that, hey, there's this RFC, there's a quad notation, we understand objects in the wire, there's a physical representation layer, there's a transport layer, right? But I think, Nadine, bringing the point back to the working groups and every other standards process that's happening now, I think there's a higher level of standard, which is, call it the application layer, right? Which is, if we go beyond the pixels, as talked about, how do we make meaning of these objects for both humans and machines in a consistent way across whatever representation, network, transport, et cetera, right? I think that's the high order bit that, and so Stephen, to your second question, I think geospatial information becomes a unifying factor, and I think someone used the term Euclidean geometry, might have been Bray, right? So, whether it's Euclidean or Riemann geometry doesn't matter, but there is something that anchors us in a coordinate system. Addresses may change, objects will change in the surface of the planet, but they are anchored to something that's agreed to be unchangeable.
I just want to take a crack at the first part of the question, actually. So this is a very humanist view on this, right? So, we exist in the physical world. Often systems do have alternate representations that are disconnected from our world. And I think one of the promises of the metaverse is potentially to create a bridge between both. I think none of us want to live in a world which is built for machines, right? So in some sense, the machines need to learn about our world. And I think the metaverse is the opportunity of providing that.
I love that. And if I were to add on to that particular point about computers not needing 3D, I think there's a ton of problems that require three-dimensional modeling that we're just at the beginning of being able to do better. So clash detection is one of these things that we've had it for a while, and we think we understand the problem space pretty well. But the nature of the problem is actually even more complex, because a lot of times when clashes occur, there's a time component. And so it's time plus space. And then other times it's, there's conflicts of multiple objects trying to be in the same space at the same time. And that's, if we just look at that from a really simple perspective, there are all these other problems that we don't model well. So electromagnetism is a really interesting problem space. Esri gets into this a lot, and it's actually pretty fun to watch them attempt to model it, because it's a very, very hard thing to imagine. But the Earth is orbiting about the sun. There's other planets orbiting about it, and we've got these waves, electromagnetic events that occur quite often. And sometimes those might actually be associated with fires or other issues that we have on the planet that we're trying to predict better. So, I think some of the things for the metaverse that would be really great is that if we had a way of perceiving a lot of these inherent natural systems, where we then, overlay our own interventions as humans, there's a lot of really interesting problems left to solve that are deeply 3D, and there are actually multiple dimensions beyond that. There's time, we have cost factors, we have other dimensions around, how these different things might occur, and also too, the world is not fixed, right? Like the event of Pangea breaking is still happening, and the Earth is changing, and I think all of those things are super, super interesting, deeply three-dimensional problems, plus some, and I think the metaverse is going to be a space where we can explore that and maybe understand it better with our own human minds.
What I want to add is the machines, they need 3D to learn about the real world. The machine will know nothing about the real world without us, so we have a lot to teach them, so it's something to remember.
That's very true. So let me take, I think it's an easy question, but let's see. This question is from Edward Dawson Taylor from Edge Visual Studios. And the question is, any thoughts on coordinate reference systems in a 3D coordinate space? Cesium seems to stream a sphere, whereas most mapping is projected to a flat world. The sphere creates interesting challenges navigating the full globe, as most engines work on a flat world principle, with gravity working downwards rather than toward the center of the Earth. So the question is there any emerging standard for 3D GIS? Philip, yeah. I think you're trying to say something. Yeah.
That's right. Yeah, I'll give this one a shot here. Yeah. So Web Mercator, there's vertical coordinates. Taking a step back, I thought getting into 3D GIS, I was actually going to be a little bit more removed from all the projection issues from 2D GIS, and was I wrong? There's a good example here recently is Next-Gen 911 in the United States. Calls are going to be coming in and you're going to be given a Z value where you're placing emergency calls within buildings and trying to identify where those callers are calling from in an effort to reduce the risk to life and the response time. There's orthometric heights, there's Euclidean heights, there's height above ground, there's all of these things that are ultimately very difficult, and all of every country has their own standards, states have their own standards in terms of coordinate systems and projections. And so it's ultimately very challenging, and it requires the flexibility of actually working with whatever the user is intending to work within at that time. In some cases, it's actually a legal requirement. So it ultimately does. That's a great question, because it does require the flexibility of being able to make information products and experiences that ultimately support that end need. No one standard.
Patrick, you were gonna say something?
Yeah, that's a great answer. Then if I can add, so for cesium, and I imagine a lot of other 3D geospatial viewers, the Earth is not, and I'm an engineer, so I apologize. The Earth is not modeled as a sphere, but it's an oblate ellipsoid. So it's a WGS84 typically. And there are, in the OGC, there's geopose for positioning models. So I think that's an interesting standard to look at. But as Philip said, I think we're always going to need a conversion piece, because there's going to be new projections and new coordinate systems all the time.
Right. So I'm gonna get one last question. I'm gonna combine them. They have nothing to do with geospatial, but I love the question by Leonard Daly from the Cronus Group. So I'm just gonna put them. And so Leonard was asking, this is at least the third time around for the or any metaverse in the last 20 years. How are things different this time than any of the others? And then, as you think about this, his other question was, I love this, what are the potential business models to pay for metaverses development and operation? It's good, isn't it?
I'd say one of the things that is not a root cause, but it's a catalyst, the fact that COVID blurred the line between real and virtual, created the comfort with people to say, there was work, there was home, there's work in home, and we're doing work right here, and none of us are present together, right? And so I think that has driven a general perception, and I think the way, my opinion on how those things tie into business models, you've got business models centered around collaboration, you got business models centered around productivity and connectivity and so on, right? So I think it's no different than how does the internet pay for itself, right?
Yeah, and I think.
Yeah. Sorry, go ahead.
No, I think, the metaverse is no more that dystopian VR thing. I think it's extension of the internet. It's, every glass panel can display digital data. And I think the odds are better because so much more technology has been commoditized over the past 10 years. The cloud infrastructure, the cost of everything has gone down. So the odds are better. It can fail. And by the way, remember the information superhighway never existed, but we still got the internet. The metaverse may never exist as the metaverse, but I think something will happen around real-time 3D, because when things become social first and you have agency over things, it's game over. Video is going to be so 2021.
And I think the thing that's interesting about that correlation is that the internet as a concept is not a business model. It's not even a thing, right? It's kind of a destination. The business models exist on things that are hosted within the internet, or how you get to it. And I think imagining the metaverse as this extension or this bridge between digital and physical, it's probably the best analogy, because it will be like early internet, where we have this really interesting thing and we don't really know what we're doing with it. but there will be new problems that we'll come up with too. So, having a standard for data interoperability, that might be similar to like the indexing problem that was presented to the internet in the early days. And so, in OG internet, a super fun time was, when you would surf, you would find pages that were like, these are the other pages we think you should look at. And that was so cool because a lot of those times, those other pages were super arbitrary and you just found really interesting things, but you were up for it. You were just going to go see what else is out there. And I think the metaverse will probably have things like that will require a very deeply technical solution to fix it, but it will also be something really fun to just experience and then just, observe as it unfolds.
I saw an interesting stat the other day, which I think reinforces our analogy, is if you add up the users of Fortnite, Roblox, and Minecraft, it's 350 million MAUs. That's probably what the internet was in 1999.
That's a pretty sobering stat there.
Yeah.
So
It's here to stay. I believe it's here to stay because already 350 million people are doing it. By the way, there are kids.
Yeah. So if I could take a quick crack at the two questions. So, I actually do want to call the maybe difference between the internet as a technology and a protocol that started with ARPANET versus the web, right? I think there's a big difference between those two things. It took the web to really open up the internet from essentially a very niche set of people. So coming to the question of monetization, I actually think it's really important. I think that the metaverse right now is obviously a peak hype cycle, and I think that if the business value is not there, I think that it's going to crash and burn very, very quickly. We believe, at least the work that we do very narrowly, sort of again taking our focus. Like I think the value right now is around synthetic data and validation. But I think the true value comes from democratizing both the digital twins and the metaverse to all other parts of the product lifecycle and the larger ecosystem, from training to optimization to operations. And again, I think we are very early in that journey. I think we're literally at the beginning of the product lifecycle right now.
Yeah, and I think someone wrote an article about value creation in this completely digital version of the world, right? So we're now in a completely different set of industries that get unlocked because the level of capital investment is very different. And then you think about what NFTs can do behind that, et cetera.
Absolutely.
We're really, really early on that stuff, right?
Yeah, I think I'm glad you brought up DeFi, because I think that's, again, if you move virtual, there's so much friction in the physical world, and there's friction to value exchange and transactions, which also we have the opportunity to somewhat look at differently in the metaverse.
I love this so much. I appreciate that you all took on the challenge of a non-geospatial question. But you can see, I think that those questions come up because you are making it real. So when people see what you're doing, they start to get the next level questions. Which is, again, I think I go back to, Patrick saying it's all about action at the end of the day, and it's all about collaboration. So with that, I really want to thank you all. So I want to thank the speakers, so Seb, Gastel, Philip, Apoorva, Ray, Mark, Patrick, and Rob, just coming together, preparing for this panel, and you're all coming in with this spirit of collaboration and partnership, and interoperability is refreshing. We don't have to make the case, and we just can get to work. And I hope we can get to work in a working group. So I'm happy to follow up on that, and then hopefully do a session at our March meeting in person, so you can show all the amazing stuff you've shown and show your real faces, I hope. And I want to thank everybody on the line who participated, asked questions. Thank you, and have a great evening for some of us, morning for some of you. Appreciate it. Thank you so much.
Thanks for having us, Nicole. It was fantastic.
Thank you.
Thank you.
Thank you.
Thank you.